A 5-kilogram watermelon is dropped from a third-story balcony 11 meters above the street. Unfortunately, the water department forgot to replace the cover on a manhole, and the watermelon falls into a 3-meter deep hole. How fast is the watermelon going when it hits the bottom? Draw an energy bar chart. Okay, so we have our system here. We've got our watermelon here, and it starts at y0 and it ends at y1. Notice that y1 is below 0, so here's my 0, and my y is at -3, so this is a negative number. And I'm going to draw my energy bar charts. So my energy bar charts, I'm going to say that this is kinetic energy here. This is UI, and then K final and U final. So my initially, I'm going to have all potential energy. So I'm going to have all potential energy, and let's just say all means 4 bars. And I'm going to have no kinetic. So my kinetic is going to be at 0. And then at the end, I'm actually, you know what? I think I'm going to undo that. I'm going to have less. Yeah. So I'm going to start and I'm going to have, let's say, I'm going to have 3 bars. So I'm going to have 3 bars. So I'm going to start with 3 bars. And then my kinetic energy is 0. And then when I finish, I'm going to have, let's say, 4 bars of kinetic energy. But I'm going to have a -1 bar. So let's see if I can erase this so you can see it better. And I'm going to have a -1 bar of potential energy. And so when we add them up, we need to have the initial and the final bars be the same height. And so if I take the kinetic final, I'm going to subtract 1 bar, and I'll get back to my. So I need this bar to be the same when I add these two together. So I'm going to have 4 bars and then minus a bar, since this is below 0, gives me back to 3 bars. Okay. So now I want to convert this into my conservation of energy equation. So conservation of energy, we have K initial plus U initial is equal to K final plus U final. And just looking at my bars, I have 0 for kinetic energy. Right, so right here I have 0, and that's why I crossed it out over here. And then I have a term for my kinetic energy final, and I have a term for my potential energy final. So I'm going to plug in. So I'm going to have mgy initial for ui is equal to 1/2 mv final squared plus mgy final. Okay, and so I'm going to bring this term over to the other side by subtracting it from both sides. So I'm going to have mgy initial minus mgy final is equal to 1/2 mv squared, v final squared. Now I'm going to combine terms, so I'm going to have mg, factor that out, mg, and then I'm going to have y initial minus y final is equal to 1/2 mv final squared. So I'm going to cancel my m's, and now I'm going to also multiply both sides by 2. And I'm going to get, so the 2 here and the half cancels. So I'm going to get v final squared is equal to 2g y initial minus y final. And so v final equals the square root of 2g y initial minus y final. And so plugging in my numbers, I'm going to have v final is equal to 2 times 9.8 meters per second squared times my initial height was 11. Right over here. These are my givens and finds that I didn't write, but were written for me. And then my final is -3. So that's what I'm going to plug into my equation. So I'm going to have 11 meters. Whoops. Undo that. 11 meters minus a -3 meters. Right, and just to double check, does that make sense? My delta y, right, is going to be the whole distance from, say, here to here. Right, and so that is 11 here plus 3 here, so that gives me the 14. So that does make sense. So v final then is equal to 16.6 meters per second. So that's my final answer.